Welcome to our Chapter 3.3a lesson video. We're going to be talking about something called polynomial division today. This is something that should be relatively new for most people, and there are multiple ways of doing this. So today we're going to learn kind of the fundamental way, the way that should refresh back to something that you might already know from a past experience in a math class. And I'm gonna introduce you to it, and it's gonna be a little tricky, but I think the best way to do this is to take really good notes and then practice the assignment, try all the problems, and then ask questions when you're getting stuck or confused about some of these problems during our live session. So let's go ahead and get started. All right, we're going to be talking about dividing polynomials. Today, this is going to be in two parts. So this is the first part. Today, we're going to use something called long division. Long division. You all hate long division, I'm sure. We're going to use long division to divide polynomials by another polynomial. Later on, we'll learn about something called synthetic division, but that's to come a little bit later, and we will talk about that in our next lesson video. All right, so first of all, if we can, the best way to simplify a polynomial by division, and division is just, it's the same as a fraction, the best way would be to simplify if everything divides perfectly by the denominator. In other words, if the denominator is a common factor of everything. If that is the case, then you can just simplify like normal. It's really usually quite nice, quite quick, and easy to do. So for example, 4x cubed over 2x, we can kind of break this apart into three different division problems. 4x cubed over 2x plus 12x squared over 2x minus 2x over 2x. Really what we're doing is we're distributing that division to all three pieces here. We'll simplify them each separately. 4 divided by 2 is 2. X cubed divided by x is x squared, plus 12 divided by 2 is 6. X squared divided by x is just x, and then negative 2x over 2x is just negative 1, because it's the same thing on top and bottom. So if possible, this is the best, fastest, easiest way to divide. But this usually only works if there is a monomial on bottom and everything is divisible by that monomial perfectly. Not always the case, though. All right, now before we get into polynomial long division, I want to refresh you on old school long division, something that you did back maybe in 2nd, 3rd, 4th grade, something from a while back. So you might have seen a problem like this where it said 17,824 divided by 25, and then your teacher had you set something else up. They had you do something like this, where you do this little house. You wrote 1, 7, 8, 2, 4. And then you wrote the little 25 on the outside, and all of us are having these terrible flashbacks to elementary school. So then you ask yourself, all right, what am I going to do? I'm going to go ahead and say, how many times does 25 go into 1? Well, 25 doesn't go into 1. How many times does 25 go into 17? Well, 25 doesn't go into 17. How many times does 25 go into 178? Finally something we can do. 25 goes into 178. Let's see. It goes into 178. Let's say 7 times. 7 times 25 would be 175. We go ahead and we make this a subtraction now, an opposite. We subtract that from the 178, and that leaves us with a 3. You drop down the 2, and you say, all right, how many times does 25 go into 32? It only goes in 1 time. 1 times 25 is 25. We go ahead and make this a subtraction now, an opposite, so they can kind of cancel out. 32 minus 25, let's see, that's going to leave us with 7. All right, we go ahead, we now drop down the 4, we get 74, and we say, all right, how many times does 25 go into 74? Ooh, almost 3, but it only goes in 2 times. So 2 times 25 is 50, 74 minus 50 is 24. Now, later on in math, you learned that you could start adding a decimal place and some zeros to get a decimal place, but early on in math, you just said, well, that's all I can do, so I'm going to say I have a remainder of 24. And that was your answer. What was 17,824 divided by 25? It was 712 with a remainder of 24. Ooh, Hopefully you guys remember doing something like that. It's a little weird, a little bit different, maybe not something that you do every day, but we're going to do something very similar, except now instead of just numbers, we're going to have polynomials and variables. So once again, this is a process. It's a process that is going to take practice. So I'd encourage you to try these next problems and then try them again and then try them again and try them again until you really get that routine, that procedure down. Watch this as many times as you need. Right? So here's how the process is going to work. We're going to rewrite it, making sure to fill any gaps with zeros. What that means is we need to have a full polynomial. So in this example we're going to do, we have an x cubed, an x squared, an x to the first, and then a constant. If there was ever a gap, say there was no x squared, we would put a 0 there. So any gaps we fill in with zeros. We then have to decide what multiplies to make the first terms match. So we'll see what that means in a second. We're going to multiply to make the first terms match. We're then going to distribute it through and multiply it to both terms. What we're going to do then is we're going to make everything opposite. So anything in this second piece we're going to make opposite. We're going to distribute this negative so things cancel out. We're then going to drop down the next term, repeat the process over and over and over until we end up with a remainder. So I'm going to go ahead and demonstrate this now. It's a little bit different. It's a little bit strange, but I encourage you to try it, try it, try it. So we write our big polynomial. Our first polynomial is what goes on the inside. That's x to the third plus 7x squared plus 14x plus 3. And then our second polynomial goes in the front. That is x plus 2. All right, so here's what we need to do. We're going to go ahead and we're going to start with the very first thing. And we're going to ask ourselves, what can we multiply x by to make x cubed? So that's always our question. What can we multiply this first term on the outside by to match our next term on the inside? Well, we can multiply our first term on the inside by x squared. That will make them match. All right, x squared times x is going to become x cubed. We're trying to make a match right now. X squared times 2 is going to make 2x squared. So plus 2x squared. All right, now here comes the part that a lot of people forget with long division. We now need to make this new row opposite so things cancel out. So we're going to make that a negative x cubed and a negative 2x squared. So everything in the second row becomes an opposite. That'll make these x cubes cancel out. That's what we wanted. And then we can now subtract this other piece. 7x squareds minus 2x squareds is 5x squareds. We drop down the next term, plus 14x. And then we repeat this process. We ask ourselves, what can we multiply by x to make 5x squared? Well, we have an x. We can multiply it by 5x to make 5x squared. So 5x times x is 5x squared. Remember, we're trying to match it right now at this point. And then we do 5x times the other piece. 5x times 2 is 10x plus 10x. This is a very repetitive process once you get used to it. I usually then draw the line, and I make the second line here opposite. So minus 5x squared minus 10x. The 5x squareds now cancel, and we subtract the other ones. 14x minus 10x becomes 4x. Drop the next term down, plus 3. Repeat the process again. You say, all right, what can I multiply x by to make 4x? Well, that one's a little bit easier. You can multiply it by a 4. 4 times x makes 4x. 4 times 2 makes 8. Draw the line and then make it opposite. Minus 4x minus 8. The 4x's cancel. You have 3 minus 8. This time that is negative 5. When you get to this point, you notice I have nothing left to drop down. Nothing left to drop down. This is what we're going to call our remainder. Now, we write our remainder a little bit differently. To write our answer, we're going to rewrite our answer down here. We're going to say x squared plus 5x plus 4. And then our remainder, we write plus our remainder divided by this original thing we were dividing by, x plus 2. X plus 2. So what we're saying there is we're saying that our -5 still has to be divided by x plus 2, but we have nothing else to drop down, and so we had to stop our process. So we're just going to leave that remainder as a fraction, as something that is still being divided by x plus 2, but we ran out of stuff to do. All right, I encourage you, if this was confusing, tricky, it is a little bit different, it is a little bit weird, back up 5 minutes, rewatch this process again until you feel pretty comfortable with it. We're going to go ahead and do a couple examples on the next slides, and I want you to really feel good with this. I think I got 2 examples left. All right, so here's our next example. I have 42x squared minus 33. Notice I'm missing the x's terms. When I write this, I'm going to put 0x in between here because I'm missing something, right? If I start with x squared, next should be x's, but there's nothing there. So I'll do that in a second. And we're dividing by 7x plus 7. So let's go ahead and let's write the problem. We're going to go ahead and draw a little thing. We'll go 42x squared. I'm missing the x's, so I'm going to write plus 0x's. So that's me filling in my zeros. Minus 33. Anything that's missing, we fill in with 0 of that thing. I then write what I'm dividing by out front. That's 7x plus 7. All right, same process as before. We're going to ask ourselves, what times 7x is going to make 42x squared? Well, to do that, we're going to need a 6x. 6 times 7 will make that 42. X times x will make that x squared. And then we also have to make the 6x multiplied by the 7. That's going to be just a 42x. Now, this is the part that everyone always kind of forgets or messes up. First, we were trying to make them match because now I'm going to make this entire second line opposite. So opposite, opposite, these cancel. That now leaves me with 0 minus 42x. If you combine those together, that's going to give you negative 42x. Drop down if you have something to drop down, so that's minus 33. Repeat the process. What times 7x is going to make negative 42x? A little bit different. This time that's going to be a negative 6. Negative 6 times 7x is negative 42x. Negative 6 times 7 is negative 42. All right, we make everything in this second line opposite. This is a little bit different this time. Since they're already negatives, we're now going to make them positives. Okay, we make them positives. That means that the negative 42x and the positive 42x will now cancel. Draw your little line and subtract 42 minus 33. That's going to be 9, I believe. All right, nothing else gets dropped down. There's nothing else here to drop down, so that means this piece right here is my remainder. So I'll go ahead and I'll write my final answer as 6x minus 6 plus a remainder of 9 over 7x plus 7. All right, so there's another example. Couple key differences on this one was there was no x term, so we put a 0x here. We filled in our 0. And then this time we had a negative, so when we matched it with a negative, we changed the negative to a positive. One last example demonstration. We look at our thing that's being divided, and right away we notice again we have an x cubed. No x squared, so I'm going to have to fill in some zeros. Minus 4x plus 6, and this is what we're dividing by. So we'll go ahead. We will write x cubed. I said there was no x squareds, so we'll go plus 0x squareds to fill in my 0. Minus 4x plus 6. You 100% have to fill in this 0. If you don't, it doesn't work. You have to really, really remember that. It's very tricky, and people will mess that up. I don't want you to mess that up, so be careful. X plus 3 goes in front. Then you ask yourself, what times x makes x cubed? That would be x squared. X squared times x is x cubed. X squared times 3 is 3x squared. Make it opposite. Minus, minus. Those cancel. You now have 0 minus 3x squared is minus 3x squared. What times x is going to make negative 3x squared? Oh, I forgot to drop down my minus 4x. I'll do that in minus 4x. So once again, what times x is going to make minus 3x squared. In this case, it's going to be a minus 3x times x is going to make a minus 3x squared. And then a minus 3x times 3 is going to make a minus 9x. All right, make that second line opposite. So the minus 3x becomes a positive 3, or minus 3x squared becomes a positive 3x squared. The minus 9x becomes a positive 9x. Both of those pieces become opposite. The 3x squareds cancel. You have 9x and negative 4x. Combine those together, it's going to be a positive 5x. Drop it down. So it's a positive 6 drops down. And you ask yourself, what times x is going to make 5x? That would be a 5, so you go plus 5. 5 times x is 5x. 5 times 3 is 15. Go ahead, make the second line opposite. The 5x's cancel. 6 minus 15 is going to be negative 9, I believe. Yeah, negative 9 sounds right. So then we don't have anything else to drop down, so we can write our answer. We write our answer as x squared minus 3x plus 5. And then I always like to write plus, even though it's a minus. And I go plus, and then on top I write my minus 9 over what we were dividing by. So over that x plus 3. You could write minus 9 over x plus 3 rather than plus negative 9. I just like it that way. I think it looks a little better to me. All right, so with that, I think you have enough information. You should probably be able to get started on the assignment. I'd like you to give it a try. Really look at it before class today. We'll do a bunch more of these examples in class. And if you have any questions, please reach out to me. Otherwise, I'll see you in our next live session. And until then, I hope you have a great day.